All right, guys, we are into chapter 6. Chapter 6 begins with properties of exponents. There's a lot in this particular section, so it's very important that you take good notes as we go through the different examples and the different rules related to exponent properties. So the first two things that we're going to talk about are the zero concept and negative exponents. So we want to know what happens when we have a zero exponent and what we do when we deal with negative exponents as well. So you want to make sure you write down this entire core concept here. First of all, when we're talking about the zero exponent, aka when we're raising anything to the zero power, whether that be 4 to the zero power, as we see right here, or we have a to the zero power, as we see here, anything raised to the exponent of 0 is just equal to 1. Okay, so anything raised to the 0 exponent is equal to 1. So I could have x to the 0, that's equal to 1. I could have 136,429 to the 0 power, that's equal to 1. Anything raised to the 0 power is equal to 1. Second part is dealing with negative exponents. In mathematics, we never want to leave anything raised to a negative exponent. So for any integer n and any non-zero number a sub negative n is a reciprocal of a to n. That's a little bit of a wordy definition, but basically all that means is you flip it. So as you can see here, you have 4 to the negative second power. How do we rewrite that? When we have a negative exponent in the numerator, it goes down to the denominator. So this would be the same as 1 over 4 to the second power. Same idea here, we have a to the negative n. That would become 1 over a to the n, as we can see there. So whenever you have negative exponents, it moves. You can't keep it where it is. Now you have to be careful. For example, if we have something like this, 4x to the negative third power. Notice the only part that's being raised to the negative exponent here is the x part. So in this particular problem, if you were asked to rewrite this, this would just be equal to 4 over x to the third power. Notice the only thing that's being raised to the negative exponent is the x part. That's the only part that's going to move. That's the part that's going to go down to the denominator. Similarly, guys, if we have something like this, maybe we have 2 over x to the negative fifth. Notice how your negative exponent is in the denominator here. In this case, again, we can't leave a negative exponent. We're just going to move it up to the top, and this would just be equal to 2x to the fifth power. So negative exponents move. If they're on the bottom, they move up to the top. If they're on the top, they move down to the bottom. So let's take a look at both of these. We have 6.7 to the 0 power and negative 2 raised to the negative fourth power. So 6.7 to the 0 power is just going to be equal to 1. Negative 2 to the fourth power. We have a negative exponent that's going to shift down to the bottom. That entire part of negative 2 is being raised to it. So this is really 1 over negative 2 to the fourth power. And if you wanted to, negative 2 to the fourth power, 2 squared is 4, 2 cubed is 8, 2 to the fourth power is 16. Negative 2 to the fourth power is also 16. So this would be equal to 1 over 16 as our answer. I'm going to add one more example in here. We're going to have an example that looks like this. 3 to the 0, x to the negative fifth, y to the third. You're asked to rewrite this. So now we're adding a couple more parts to this, but you want to go each part by itself. So let's do the 3 to the 0 part. Well, 3 to the 0 is just going to be equal to 1, because anything raised to the 0 exponent is equal to 1. So 3 to the 0 is equal to 1. Now let's go ahead and do our next part, x to the negative fifth. Well, x to the negative fifth, I can't have a negative exponent, so I know I'm going to drop that down to the bottom. So that's going to be 1 over x to the fifth. And now let's do our last part. Y to the third, there's nothing to do with that, so that's going to stay up top where it originally was. So I'm going to have y to the third up top. Most simplified version would just be y cubed over x to the fifth. So you want to go step by step when you're going through these examples. Do you have anything raised to a 0 exponent? If you do, that's just going to be equal to just straight 1. Do you have a negative exponent? If you have a negative exponent, you need to move it. If it's on the top, it goes down to the bottom in the denominator. In the denominator, it moves up to the top. Okay, and then you simplify in any way that you can. Again, here's another example for us to try. Let's look at each part individually. So we've got 4. 4 is separate. Then we have x to the 0. And then we have y to the negative third. The 4, there's nothing to do with. So we're going to keep it as 4. X to the 0, we know is just going to be equal to the number 1. It's not x to the first. It's just equal to the number 1. So we have 4 times 1 up top. And then that y to the negative third has to move up to the numerator and become positive. Well, 4 times 1 is just equal to 4. Move that y to the negative third up top, and your most simplified version here is just 4y to the third power. We'll look at the try these in class. A lot on this page, so let's take a look and break it down step by step. We have a lot of different properties here. We have the product of powers property. We have the quotient property. And we have the power of a power property. This is all about understanding and knowing your rules. So the first example that we see is when we're multiplying powers together. And it's very important that you write these examples down. So we've got 4 to the 6th times 4 to the 3rd. Notice that my bases are the same. That's crucial. They have the same base. So if they have the same base here, we're multiplying 4 to the 6th times 4 to the 3rd, notice what you do with your exponents, you add them. You add them together. So you would end up getting a simplified version of 4 to the 9th. So when we have a to the m times a to the n, when we're multiplying exponents together, we add them. So if we had something like x to the 6th times x to the 4th, we would add those exponents together, and we would get x to the 10th power. Okay, so when you're multiplying, you add the exponents. Similarly, hopefully you're thinking by that same reason, quotient property, when you're dividing, notice same base, 4 to the 6th over 4 to the 3rd, what do? We subtract the exponents. So when you're dealing with a quotient and you're dividing, you subtract the exponents. Similarly, if I had something like this, x to the 8th over x, that's really x to the 1st, subtract the exponents, and you would get x to the 7th as the simplified version. Finally, we have power of a power. When we're taking a number and we're multiplying, or we're raising it to a second exponent, that's the case when you multiply those exponents together. So we have 4 to the 6th raised to the 3rd power. That means that we multiply the exponents together, and we would get 4 to the 18th power. Similarly, if I had something like this, x cubed, and I wanted to square that, I would multiply those exponents together to get x to the 6th power. Why do we do that? Because x cubed squared is really x cubed, x cubed is really x times x times x, and we're doing it a second time. So we're squaring it. X times x times x. Well, what am I left with? I'm left with 6x's, x to the 6th power. Okay, so that's where this is coming from. Very important. Make sure you have this down, because we're going to start to combine all of these different rules together. Let's start a little simple here. Okay, we're going to simplify each expression here. We're going to write our answer using only positive exponents. So notice right here, we have our first rule, our product of powers. So we're multiplying the two exponents together. They have the same base. So we can just add those exponents together, and you would get 3 to the 8th power. In our second example, we're dividing. So we're going to subtract them. You're going to get -4 to the -5th power. But notice it says use only positive exponents. So now we have to go a step further from this. Going back to our first rule, we have a negative exponent, so we're going to write that in the denominator, and we're going to get 1 over negative 4 to the 5th. If you want to simplify that, you can simplify what negative 4 to the 5th power is, or you can just leave it like that. And our final example here, letter C, this is power to a power. So we're taking z to the 4th, and we're raising it to the negative 3rd power, so you have to multiply the exponents here. So we had an adding of exponents in our first example. We subtracted the exponents in our second example. And in our third example here, we need to multiply the exponents. So we're going to get z to the negative 12th power. Once again, we don't want that negative exponent, so we're going to slide it down to the denominator. We're going to get 1 over z to the 12th as our simplified answer. All right, so now we're using our rules, our new rules, and sometimes our old rules too. We'll look at the try these in class. Final example that we have to look at is the power of a product example. Okay, so this is when we have something where we have a fraction in our parentheses, or we have a fraction, or we're multiplying two things inside of our parentheses. In that case here, notice what's happening. That exponent on the outside is going to each individual part that's inside the parentheses. So I have that m there, it's going to each part inside the parentheses here. Same thing if it's a fraction, that 5 is going to everything that's in there. So it might be easier for you to see an example that has multiple parts. So say we have 3x cubed y to the 4th, and we're raising this all to the 2nd power. That 2 is going to go to everything. It's going to go to the 3, it's going to go here to the x, and it's going to go here to the y. So we end up getting 3 squared, power to a power here, x to the 6th, y to the 8th. And you would get 9x to the 6th, y to the 8th as your most simplified version. So notice that exponent is going to every single part. Similarly, if I had a fraction, maybe I had 3 squared, well, I'll keep it just as 3. 3x to the 4th over y squared. And I wanted to raise that all to the 3rd power. That cube on the outside is going to go to everything. So you'd end up getting 3 cubed x to the 12th over y to the 6th as your answer. And 3 cubed, you can simplify to 27 if you want it. But notice that exponent is going to everything that's involved in there. Okay, so now we're ramping it up a little bit. We're doing a little bit more with our exponents. So let's take a look at this. Simplify each expression. Again, we need to use only positive exponents. So if we look at our first example, this squared is going to both parts there. So we're going to have negative 1.5 squared y squared. There's no negative exponent here, so I can leave that just like this. If I wanted to do negative 1.5 squared, I could do that. I can do 1.5 times itself, which would end up getting me 3.25. Okay, or I can just leave it like this if I wanted to. In our second example, give that 3 to both parts here. You're just going to get a cubed over negative 10 cubed. Again, the number is negative, but the exponent is not, so I don't have to move anything, and I leave that as my final answer. Common error on this one, don't forget to give that 4th power to the 3 as well, and not just the d. Lots of times we'll see this, 3 to the d, 3d to the 4th over 2 to the 4th. But remember, that power of 4 has to go to everything, every single component it needs to reach. So we'd end up getting here 3 to the 4th power, d to the 4th power, over 2 to the 4th power. Now, if you want to simplify this, you certainly could. we do 3 to the 4th power, 3 squared is 9. 3 cubed is 27. If we take 27 times 3, we're going to get 81. So we can simplify this to 81d to the 4th over 2 to the 4th power is 16. That's really the best answer that we can get. Last example here. Got to give this -5 to everything. Again, it goes to every component. So we're going to have 2 to the -5th, x to the -5th, over 3 to the -5th. I have a lot of exponents here. Got to move a lot of things. The 2 is going down to the bottom, the x is going down to the bottom, and the 3 is going up to the top. So we'd end up with a final answer of 3 to the 5th power. And again, you can simplify that if you want. Over 2 to the 5th power, x to the 5th power. There's nothing else to be simplified. I can't do anything with that 3 and that 2. They don't have the same base. So that would be my final answer there. We'll look at the try these in class, as well as some of the word problems. I do want to look at one more example in here. I'm just going to do it on this slide here. We're going to do an example where we have to put a lot of these things together in one particular problem. So let's take a look at something like this. And you might see something like this. So there's a lot going on in this particular problem that I've written down, but I want to take this step by step. You'll see it's not that terrible if you go step by step by step. So let's go step by step. What do I want to do first? I wanted to give this -2 to everything on the top. When I do that, I'm going to have 4 to the -2nd power, x to the +6th power, y to the -4th power, z to the -2nd power. And this is all over 12, x, y to the -8th, z to the -2nd. Now, you have several options from this point. If you want to, you can move all your negative exponents first, which is not a bad idea. So I have a -2nd, 4 to the -2nd, I can slide that down. These y's are going to flip, and these z's are going to flip, and everything's going to be positive. So then I would have x to the 6th up top. My y to the -8th went up to the top to get y to the 8th. The z to the -2nd went up to the top to become z to the 2nd. On the bottom, that 4 to the -2nd ran down, so now I have 4 to the 2nd. 12 is still at the bottom. X is still on the bottom. The y to the -4th went down to the bottom to become y to the 4th. And that z to the -2nd up at the top went down to the bottom and became z to the 2nd. From this point, you're really just doing each thing individually. So line it up and do them. You've got an x to the 6th and an x. What do I do with those exponents? I just subtract them. So what am I going to get? I'm going to get x to the 5th power. I like to cross them out as I go along. So I just dealt with my x's. When I dealt with my x's, I got x to the 5th power. I want to deal with my y's. Y to the 8th over y to the 4th is just going to be y to the 4th power. Subtract those exponents. Z squared over z squared is z to the 0, or they just canceled out. It's just equal to 1. So I don't have to write my z's. What is this over? It's over 4 squared, which is 16, times 12. And I could simplify that a little bit more if I wanted to. X to the 5th, y to the 4th, 16 times 12 is going to get me 192. So over 192. And that's my best answer right there. So it might have looked a little bit confusing and complicated in the beginning, but you take it step by step, and it's not that challenging or as challenging as you might have initially thought. That's it for the lesson. I know there's a lot in here. We're going to do lots of practice with it, and I'll see you in class.